Now we're going to construct parallel lines using the copy and angle method. So there's more than one way to do it, but this one's the one that we're going to learn first because we learned how to copy an angle. So first thing we're going to do, because what we're trying to do is we're going to take this red line and we want it to go, we want to have a parallel line. And we want that parallel line to be down here that goes through point C. So it's kind of like taking the line and we're going to translate it straight down there. So to kind of help you understand what's going to happen with that, the very first thing we're going to do is we're going to draw a line that goes through the line that we're trying to make parallel. And it also has to go through point C. That's called a transversal. It goes through the line and through point C. And what we're going to do, since it's the angle copy method, we're going to copy an angle. Because if we want this line to be parallel, we're basically taking that angle. That's pretty bad. And we're going to translate it down to right there. So if you just take that angle and translate it down to point C, this is going to make a parallel line right there. So that's the idea. We're going to copy this angle to point C. So you should remember to copy an angle. The first thing we do is a reference arc. So we're going to just make an arc right there. And we want to make that same arc where we're trying to copy the angle. So we're going to move the point of our compass down to C and make that same arc. Then to copy the angle after you make your reference arc, you have to measure that arc. So you measure the opening of the arc right there. And we're going to copy that down to the arc where we're copying. So now we have point C and we have this little X that we made. That creates the parallel line. Right there. Those lines are parallel. To mark that two lines are parallel, you can put these little marks on it, like a little arrowhead in the middle of each line. That shows that they are parallel. A little arrowhead in the middle of the line shows that they are parallel. So back in Unit 1, we learned that translations move each point the same distance along parallel lines. Translations move each point the same distance along parallel lines. They move it in the same vector, so it has the same distance and direction. Same magnitude and direction. So what we need is a bunch of parallel lines to this vector. So we need a parallel line to M, vector M, that goes through A, another one through B, and another one that goes through C. So we need 3 parallel lines. So to get those parallel lines, you draw a line that goes through the point you want and through the line you're trying to copy. And we're going to try to copy that angle to right about there. The highlighted angle to the highlighted area. That's what we're going to try to do. So when you copy an angle, you start with your reference arc. And you do the same thing where we're trying to copy it. Then you measure the distance. And you mark it so you get the same distance. So that's our parallel line. It goes through A. And through that little intersection. So now we've got the parallel line. We just need the distance that it moves. So all you need to do is you need to measure how far is that vector. The vector is that long. So on the line we just copied, that's how far we're going to move it. Right there. So A moves right here to A prime. Not yet. So looking at these lines, I can tell they're a little bit off. Part of that is because this reference arc was so small. If your reference arc is small, you're more likely to get a mistake. So on the next one, we're going to do a better reference arc, a little bit bigger, further out. So we're going to draw from M again through, go in alphabetical order, through B. And this time, I'm going to do a bigger reference arc. Has to touch line M, but it also has to touch the transversal line we just drew. We're going to do the same thing down here from B. I'm going to have to extend my transversal. I stopped a little short. So now we're measuring the purple arc. So there's the length of the purple arc. We want to measure it from the transversal. I almost messed up, went to the wrong point. Transversal to the red line that we're trying to make parallel. So once you've got that length, you're going to take it back down here to the purple arc. And you've got your intersection from there through B. I think that looks a little bit better than the first one we did. So now we've got the parallel. Now we need the length. So again, that vector, to measure it with your compass, and that's how far we're moving. Our line disappeared. Hold on. Along this parallel line, that's how far we need to go from B. So from B, it needs to go that far away. And that's our new B point, the B prime. And the very last thing we need is one more parallel line that's going to go through C. So it's those same steps one more time. Needs to go through our line and through point C. So through line M, vector M, and also through point C. So just for an idea of what we're doing, again, here's the angle we're going to try to copy, and we want to put that right there. We're trying to copy the highlighted angle for this down here to point C. So to do that, you need your reference arc. Let's go to color, go green. There's our reference arc, and we want that same reference arc down here on point C. Then you measure it. And we want that same distance, that same length. Right there. And you can see how that kind of followed the highlight, just like I intended. And then for the third time, because it's the third point we moved, we need to measure the length of the vector. And that's how far from C we go out to get C prime. So connect those points. And you can see here's the original triangle. Kind of got lost with all those lines. That's translation over to there.